Have you ever been to the doctor for an eye checkup? If you're going to the doctor for an eye checkup and he tells you that your eye power has increased or decreased, he will prescribe eyeglasses for you. Now, if you see an eyeglass, you will notice that it is made up of glass. Now, why do you think our eyeglass is made up of glasses and not any other material? Let's say, for example, diamond. Why do you think eyeglasses are not made up of diamond? Because as we know, glass is transparent and so is diamond. Light travels as easily through glass as it does through diamond. Or for that matter, why do we not use amber? Because even amber is transparent. Why only glass? Let us find out the mystery behind this. We know that when light travels from one medium to another, it bends. But do we know how much light bends in different media? Now, the amount of bending when light travels from one medium to another medium can be measured by a physical quantity. This physical quantity of how much light bends when it travels from one medium to another medium is given by the refractive index of the medium. Now, before we find out what the refractive index is, let us recapitulate something. We learned what Snell's law was. Do you recall what Snell's law was? Snell's law was that for a given pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. In other words, what can we say? We can say that sine I divided by sine R was and is a constant. Thus, sin I by sin R is a constant, and this is known as Snell's law. Now we are given two facts. We are given that the speed of light in air is 2,99,700 kilometers per second. And we are also given that the speed of light in glass is 2 lakh kilometers per second. Now, from this information, we can calculate the refractive index of glass. Let us find out how. If we divide the speed of light in air by that of the speed of light in glass, we come up with 2,99,700 kilometers per second divided by 2 lakh kilometers per second. And the result we get is equal to 1.5. This is known as the refractive index of glass. And if you recall from our previous lecture, this is the same value as we obtained if we got the ratio for sin I and sin R. Thus, this value 1.5 is equal to the value we obtained if we took the ratio of sin I and sin R. And we also learned that this value is constant for a given pair of media. In this case, air and glass. So what can we say? We can say that this constant is known as the refractive index of medium 2 with respect to medium 1. In this case, medium 2 is glass and medium 1 is air. And how did we obtain the refractive index? By the speed of light in air divided by speed of light in glass. Now we have learned two methods to find out the refractive index of a medium. The first method that we studied said that the refractive index of medium 2 with respect to 1 is sin I by sin R. And the second method that we studied was that the refractive index of medium 2 with respect to medium 1 is the velocity of light in medium 1 divided by the velocity of light in medium 2. Now, even when we consider refractive index, there are certain points that need to be kept in mind. That is, refractive index can be of two types. One is relative refractive index and the other is absolute refractive index. Now let us find out what these two terms mean. Relative refractive index is when we are considering any given pair of media. In that case, refractive index of medium 2 with respect to medium 1, as we learnt, will be given by the velocity of light in medium 1 divided by the velocity of light in medium 2. This is the refractive index of medium 2 with respect to medium 1. And we also have the absolute refractive index. In case of absolute refractive index, we consider that there is one medium and the other medium is vacuum. Or in other words, we know that the velocity of light in vacuum is 3 into 10 to the power 8 meters per second. So if we are asked to find out the absolute refractive index of a medium, we will divide the velocity of light in vacuum by that of the velocity of light in the given or mentioned medium. In other words, since the velocity of light in a vacuum is known to us, that is 3 into 10 to the power 8 meters per second, we will get the velocity of light in the medium that will be given to us, and this ratio will give us the absolute refractive index of the medium. Now we have been given with this information, as you can see on the board. We have been told that the refractive index of glass with respect to air is 1.5 and the refractive index of diamond with respect to air is 2.4. Now with this information, can you tell me in which medium light would bend more? Let us find out mathematically how we can arrive at a conclusion. Notice this diagram over here. Here, an incident ray marked in blue is incident at the air glass interface. Now, at the air glass interface, the incident ray encounters a change in medium, so it is refracted and it bends towards the normal. This refracted ray travels on in glass. Now, since glass is denser than air, the refracted ray is bending towards the normal. The angle of incidence in this case is given by I, and the angle of refraction is given by Rg. G because we are considering glass in this case. So what is the refractive index of glass with respect to air? It will be given by sin I by sin Rg. So as we have been given, sin I by sin Rg is 1.5, and this is the refractive index of glass with respect to air. Now consider another diagram. In this diagram, another ray of light is incident on the air and diamond interface. This incident ray is given by the blue ray. Now since it is encountering a change in medium at the air diamond interface, and since diamond is denser than air, the refracted ray again bends towards the normal, or in other words, it shifts towards the normal. Here the angle of incidence is given by I, and the angle of refraction is given by Rd. And as we have been given that the refractive index of diamond with respect to air is 2.4, and we know that the refractive index of medium 2 with respect to medium 1 is sin I by sin R. So in case of diamond, it is sin I by sin Rd, D for diamond, that is equal to 2.4. So now we have two equations in front of us. We have that sin I by sin Rd is equal to 2.4. We call this equation 1. And we have sin I by sin Rg is equal to 1.5. We call it equation 2. Now in order to find out a relation between the respective refractive angles, we divide equation 1 by equation 2. That is, we perform 1 upon 2. Let us see what we get. We get sin I by sin Rd whole divided by sin I by sin Rg, and that is equal to 2.4 divided by 1.5. Now here we find that sin I is common, so we can cancel it. What do we get after this? After simplification, after cancelling sin I, we get sin Rg by sin Rd is equal to 24 by 15. That is, if we remove the decimal point, since both have one number after the decimal point, we can write it as 24 by 15. Now, if we calculate this ratio, we find that this ratio, that is the right hand side, is greater than 1. So we can say that sin Rg by sin Rd is greater than 1. And from this, what can we conclude? We can conclude that sin Rg is greater than sin Rd, and thus we can conclude that Rg, or the refractive angle in glass, is greater than Rd. That is the refractive angle in diamond. The angle of refraction in glass is greater than the angle of refraction in diamond. So let us find out what this means. Observe this diagram closely. Here, both the cases are taken together. When a ray is incident from medium 1 to medium 2, if medium 2 is glass, the refractive angle or the angle of refraction is Rg, and it is given by the ray with the blue arrowhead. And if the medium is diamond, then the angle of refraction is Rd, and it is given by the red arrowhead, the refracted ray. And as we have learned just now and proved that Rg is greater than Rd, so what can we say? We can say that the angle of refraction of glass is greater than the angle of refraction for diamond. And as we can see that when the angle of refraction is greater, the bending is lesser. So we can say that if the angle of refraction is more, the bending of light will be less. And if the angle of refraction is less, the bending of light will be more. So in glass and diamond, the angle of refraction is less for diamond, and the bending of light is more in diamond. So light bends more in diamond. Now we found that the refractive index of diamond with respect to air, which was 2.4, is greater than the refractive index of glass with respect to air, that was 1.5. In other words, we can say that the ratio between the velocity of light in air by the velocity of light in diamond is greater than the ratio of the velocity of light in air to the velocity of light in glass. And we know that this ratio gives us the refractive index of medium 2 with respect to medium 1. Thus, since velocity of light in air is common in both terms, it can be eliminated. So what can we say? We can say that the velocity of light in glass is greater than the velocity of light in diamond. So what can we conclude from this? We can conclude that the speed of light in diamond is lesser than the speed of light in glass. And we have also learned that the refractive index of diamond is greater than the refractive index of glass. So greater the refractive index, lesser will be the speed. And thus we can conclude that diamond is optically denser than glass. So since light from optically rarer to optically denser medium bends towards the normal, we can say in case of diamond, light bends more towards the normal than it does in glass. And when light travels from an optically denser to an optically rarer medium, light bends away from the normal because the speed increases. So now can you answer why eyeglasses use glass and not diamond and amber? As we learned, when light travels from air to diamond at the air-diamond interface, bending of light occurs to a great extent. Due to this bending of light, we are not able to see clearly. We would not be able to see clearly if the eyeglasses were made of diamond. Similarly, if we used amber, the bending of light would occur to such an extent that we would not be able to see clearly what lay in front of us. Thus, this is the reason why we are using glass, because it provides an optimum amount of bending of light. So taking a quick recap, we learned that when light travels from one medium to another, light bends. This bending is determined by a physical quantity that is known as the refractive index. Refractive index can be found out through two ways. The first way of finding out refractive index is by calculating the ratio between the sine of the angle of incidence to the sine of the angle of refraction. The second method to find out the refractive index is by finding the ratio of the velocity of light in medium 1 by the velocity of light in medium 2. Both these gave us the refractive index of medium 2 with respect to medium 1. We also learnt that light bends more in diamond than in glass, and we proved it mathematically that the angle of refraction for glass was greater than the angle of refraction for diamond. That is, more the angle of refraction, lesser was the bending. And that was the reason why we used glass in eyeglasses instead of diamond. We also learnt that when light travels from a rarer, an optically rarer to an optically denser medium, the speed of light decreases and the path of light bends towards the normal. And when light travels from an optically denser to an optically rarer medium, the speed of light increases and the path of light bends away or shifts away from the normal.